Hey guys, so today we are going to try to understand what is lattice energy. So let's get right into it. So before understanding what is lattice energy, we should at least give it a thought what exactly is a lattice, right? So what is a lattice? So guys, lattice is an abstract arrangement of points. So it's an abstract arrangement. You do not have physical location, but it's an abstract arrangement of points where each point represents ions. So we define lattices for ionic solids. First of all, we should be very much clear what lattice is. It's an abstract arrangement of ions. Now, what is the lattice energy? It is the energy change, as you can understand, lattice energy change that happens when 1 mole of ionic solid dissociates into 1 mole each of its gaseous constituent ions. So, let's say you have the 1 mole of NaCl salt. S indicates that it's solid. Now you have to understand how did it form in the first place. So let's go right on to it. Okay, so sodium is found as a solid, whereas chlorine is found as gas Cl2. Now this sodium must be converted into gaseous phase. Chlorine itself already is gas, but we need atoms first of all. So chlorine must break into chlorine atoms, obviously in gaseous phase. Now remember, there is a tendency all atoms want to fulfill their octet because it's very stable. So sodium, which is 11, that is 281, wants to lose this extra 1 electron, whereas chlorine, which is 287 because it's 17, wants 1, right? So these gaseous atoms want to interact. So Na loses 1 electron and this electron is gained to chlorine, and then we have Na plus and Cl minus ions arranged as a solid, and this is what is exactly a lattice. Now the energy associated in the transformation of gaseous sodium and chlorine ions, remember, gaseous sodium and chlorine ions to solid sodium chloride, that is lattice energy. Now let us be very clear, we are talking about the transformation of ions into the solid here. Now why should there be a change? You have to understand Na plus and Cl minus, they would be very well together. Why? Because there is an electrostatic attraction between them. Right? Why? Sodium has just lost an electron and chlorine has gained one. They are negative charges. So when these two charges are brought closer to each other, there will be a release of energy. Why should there be a release of energy? Simply because it's better that they are closer. If you keep two charges which are opposite to each other, away from each other, you need energy to do that. So lattice energy, in terms of mathematically speaking, is a measure of bringing charges Q1, Q2. Q1 represents the charge on sodium, Na plus, that is plus 1.6 into 10 to the power minus 19 coulomb. Q2, again, that is the charge on Cl minus 1.6 into 10 to the power minus 19 coulomb by R square. That means we are bringing them from infinite distance to R, where R represents the bond length. So this is the lattice energy that will be released when they are brought closer. In this case, that happens to 786 kilojoule per mole. Now, if you're wondering what is the value of R, so R can be determined experimentally, that is 2.82 into 10 to the power minus 10 of a meter, and K is a physical constant, that is again 8.99 into 10 to the power minus 9 meter per coulomb square. Now, this should make sense. I mean, why sodium that needs to lose one electron to form Na plus and Cl that needs to gain an electron to form Cl minus combine all together? I mean, if the process does not need to a reduction in the energy, then it should not happen, right? So why it's happening? Because of this. So remember, to pull out an electron from sodium, it takes energy. To add an electron into the chlorine, it takes energy, right? Where does that energy come from? So this energy eventually required, the energy that is required to do those processes, to turn them into gaseous ions, is less than the energy that would be released as lattice energy. So that is why this whole reaction is favorable in the first place. So that is what the importance of lattice energy is, the energy change that occurs when 1 mole of ionic solid dissociates and you get the gaseous constituent ions. So actually why it's happening, the story is somewhat the opposite. The gaseous ions, they convert into the solid because it's energetically favorable. I hope this makes sense.
We hope this video was helpful. To see more biology topics covered, click on our channel and don't forget to subscribe.